So, standard normal variate, there is a probability curve here, probability it is given here. So, this is kind of, it is called a probability table for a standard normal distribution function. Now, for using this standard normal distribution function, we can find the probability like this. Suppose if you have z is normal 0 1, so that means it is standard normal. So, what will be the density function? F of z is nothing but 1 by root 2 pi e to the power of minus z square by 2 z square by, this is the density function. Now, what is the cumulative distribution function? For standard normal variate, this cumulative distribution function CDF of z is, it is denoted as, this is a standard form phi z. So, phi z is nothing but, this is the actually fz, basically this is notation is we use phi z because it is a some kind of special distribution we use minus infinity to z fz t dt. Now, this is nothing but minus infinity to z fz t is nothing but 1 by root 2 pi e to the power of minus t square by 2 dt. So, this is again intractable. So, this is nothing but you have this distribution density function like this. So, for any z here, suppose z is this value, you want to find this area under this curve. So, this area for z anywhere here, this area you cannot, either you can find it numerically, it needs some computation. Now, if you use this table, then you can easily find this probability. So, how you can use this table? Suppose you want to find some value minus 1.2 suppose. So, then you can see that here this area it is given minus this value, suppose here is minus 1.2, you can see that this value is minus 1.2. So, this value, this probability will be 0.11507 this value. So, phi of, we say that if we take this phi of minus 1.2, so z is minus 1.2, this can be found here minus 1.2, this is 0.11507, 0.11507. So, this in this way, in the negative, all this negative value it is given, because by symmetry, suppose if you z is here, so by symmetry this probability actually this probability will be same as this is z, suppose this z is positive, then minus z we want to find. So, then by symmetry we can find this probability, so you can find this probability also. So, then this probability will be, because this is this total 1, so this is half, total this half and this also half. So, this probability also you can find by subtraction from the half minus of this area. So, in this way we can find any probability, because all these negative value all these probabilities are given. Not only that, these probability are given up to 2 decimal place, like minus 1.21, then this is the probability. So, this is minus 1.21, this is this column you can see the minus 1.21, then 0.11314. So, that is why. So, this is phi of minus 1.21, this is nothing but the second decimal place, this is nothing but 0.11314. So, this is nothing but 0.11314. So, in this way we can find any probability. Now, whenever you know the probability of the standard normal variate, so now suppose you want to find the, suppose x is any normal distribution with any mean mu and variance sigma square, and now you want to find the this value fxx. So, this is nothing but probability that x less than equal to x. So, this is also not tractable, because this integration it will be nothing but minus infinity to x 1 by root 2 pi sigma, this is the density function of the normal distribution with mean mu and variance sigma square dx. So, you cannot find this easily. So, you have to do numerical integration value, but we can use this transformation. So, because z is equal to x minus mu by sigma, it has a normal 0 1. So, what we will do, this probability is equal to probability that x minus mu by sigma is less than equal to small x is a real number, x minus mu by sigma. Now, this is x minus mu by sigma is nothing but z is less than equal to x minus mu by sigma, and this value we know, this z less than equal to some value. So, this is the probability, actually, this is probability that z less than equal to small z minus mu to plus z, this probability. So, this value we can find out, this is nothing but by notation it is phi of x minus mu by sigma. So, x minus mu and sigma are known, and then small x, given any small x value, x minus mu by sigma we can find out, and this is from the table we can compute this probability, So, if you have understood this, or we can do some more numerical examples also. By numerical example, it will be more clear how we can use the table and you can find the probability. Let us discuss some numerical example for using normal distribution. So, one problem, let x be a normally distributed random variable, let x be a normally distributed random variable normally distributed random variable with mean of x is equal is 12, mean of x 12, and standard deviation. So, standard deviation is nothing but the square root of the variance. So, with standard deviation 4 is 4. So, mean is 12. So, let x be a normally distributed random variable with mean of x is 12 and standard deviation is 4. Find out the following probability of the following. Find out the probability of the following. So, some of the probability you have to calculate. So, what are those? 1, x is greater than equal to 2. What is the probability that x greater than equal to 2? X is less than equal to 20 and x is 0 less than, so third is that, and third 0 less than equal to x less than equal to 12. So, let us find out this probability, and the so there are some other questions also, we will do that. So, whenever x is normally distributed random variable mean 12 and standard deviation is nothing but sigma. So, mean mu is equal to 12 and sigma is, it is given, sigma is square root of the variance standard deviation. So, standard deviation is nothing but sigma, it is 4. So, which is implies sigma square equal to 16. So, it is nothing but normal mu variance sigma square is equal to 16. X has a normal distribution mean mu 12 and variance sigma square equal to 16. Now, suppose you want to find this probability that x greater than equal to 20. So, we can just, so what we will do, how to find that? So, just we mention it that whenever we want to find probability with respect to something, so we will take some kind of transformation with any mean normal distribution x having mean mu and variance sigma square, probability that x less than equal to x we want to find, or any probability you want to find. Earlier also we discussed that, like you want to find any probability, we will take a transformation such that it is nothing but with respect to the standard normal variate. So, that we can use this table we can use and find the probability, because we cannot just do this integration easily. So, you need numerical approach and we need computational technique. So, to do the numerically to do the integration. So, now x greater than equal to 20. So, what we will do? We will subtract the mean mu is nothing but 4 and divide by the standard deviation sigma. So, x is mu is 12. So, x will take this transform subtract 12 and divide by standard deviation 4. So, this inequality will be same if we do the same thing in the right hand side also, 20 minus 12 by 4. So, this is equal to nothing but now z is equal to now x minus mu by sigma, which is nothing but x minus 12 by 4 for this case. So, this is nothing but z greater than 20 minus 12 is 8. So, 8 by 4. So, this is nothing but probability that it is asking z greater than 4 by 8 is equal to 2, z greater than 2. Now, z is a standard normal variate. So, this is suppose this is the standard normal distribution, just approximately this curve, and this is 1, this is suppose 2, similarly it is minus 1, this is minus 2. Now, z greater than 2, if you want to find like this area, this will be by symmetry same as z less than equal to, so this is same as by symmetry z less than 2 or less than equal to 2, because it is continuous distribution, this is does not change. So, this is like same greater than equal to if you write. So, same as the just if you write only the inequality greater than, or if you write greater than equal to, this will be same. Now, because this will be minus 2. So, this will be z greater than equal to this area, this will be same as z less than equal to minus 2. So, this is z less than equal to minus 2. So, this probability we can find using the table, because z greater than equal to minus 2. So, this probability for negative values, this is given in this table. So, here is this table is here. So, minus 2 we will find out here, this is the minus 2, this probability is nothing but 0.02275. So, this probability is same as 0.22, sorry, this is nothing but 0. So, let us see this. So, minus 2 0.02275, 0.02275. This is the probability. Now, next question is that what is the probability x less than equal to 20? So, we found that probability x greater than equal to 20. So, probability x greater than equal to 20 is nothing but 0.02275, we found that. Now, x less than equal to 20, so see, note that because it is a continuous random variable, it is same as x greater than 20, because if you write equal to or greater than equal to at a point, the probability is 0. Now, probability x less than equal to 20 will be nothing but 1 minus probability of x greater than 20, because it is a complement of this random variable. So, this is nothing but 1 minus 0.02275. So, what about the value? So, this is nothing but 52779, 0. So, approximately this is the value, this is the you can check that this computation is correct, then this will be the probability. So, next it is asked what is the probability x greater than equal to 0 less than equal to 12. Probability that x less than equal to 12 greater than equal to 0. So, now again we have to take this transformation, z is x minus 12 by 4. So, then we will see that this is nothing but 0 minus 12 by 4, this is the transformation x minus 12 by 4 less than equal to x minus 12 by 4 less than equal to 12 minus 12 by 4. So, basically this probability is nothing but probability that it is minus 12 by 4, this is minus 3 less than equal to greater than this is x minus 12 by 4, it is the random variable z normal 0 1 less than equal to 12 minus 12 is 0. So, this probability is nothing but if you take this curve, normal distribution curve. So, this is just approximately I am trying to draw it to understand this. So, basically suppose this is 1 2 1 2 3 3. So, minus 1 sorry 1 2 3 minus 1 minus 2 minus 3. So, then basically it is asking, sorry, not this thing, it is asking the probability that it is between z is between -3 and 0. So, now we can find the probability of these things, this probability from the table. So, this is nothing but because total probability here it is half. So, this is nothing but half minus, so that means half is nothing but 0.5, 0.5 minus probability that z is less than equal to minus 0.3 or z less than 0.3, same. So, this probability. So, now because then this is nothing but this probability total half minus this probability. Now, probability z probability that z less than minus 0.3 it can be found from the table. So, up to -3 this probability 0.00135. So, 0.00135 that we have to subtract here. So, 0.5 this is nothing but 0.5 minus 0.00135. So, that is we have to compute what is the value. So, this is nothing but 5, 6, so then 5, 6, then 8 and then this is 9 and this is 4. So, 0.49865. So, this probability is nothing but 0.49865. So, some other problems also it is asked. So, second is that B, find x dash when probability x greater than x dash is equal to 0.24. Find x dash some point, find x dash such that when probability that x greater than x dash this is equal to 0.24. So, this probability is given, you have to find this value. So, how we can find that? So, so x greater than x dash we do not know. So, we will take this transformation again. So, which implies probability that some x minus mu is 12 here and standard deviation 4 greater than x dash minus 12 by 4, this should be equal to 0.24. So, we can find this value. So, that is nothing but probability that z greater than z dash this is equal to 0.24. So, z is nothing but the standard normal variate 0 1, z is x minus 12 by 4 and z dash is nothing but x dash minus 12 by 4. So, if you can find z dash then we can solve it and we can find the values of x dash also. Now, how we can find this z dash? So, this is nothing but, so we want this probability 0.24. So, it is the normal distribution curve. So, suppose this is it will not touch like that. So, z greater than z dash some value z dash here z dash. So, this it is greater than 0, this is nothing but 0.24. So, by symmetry this minus z dash this value we can find here, this will also be 0.24. So, from the table we have to find which probability actually, probability we have to say there is a inverse things, you have to find a probability 0.24 such that this z dash actually correspond this value. So, 0.24 where it is appearing. So, some of the minus something 0.24 we have to find out. So, 0.24 may be here 0.23885 and then 0.23885 and this is 0.24. So, exactly because it is just a table some up to some decimal places it is given, either we can consider this value 0.23885, it may be close to the 0.24 or we can consider this value 0.24196, this is also close to the value 0.24. So, basically it is minus 0.71 approximately, this is corresponding. So, this is close to suppose 0.24, then this value correspond to the value z dash is minus z dash is minus 0.71. So, then we get that minus 0.71. So, z dash will be equal to, this is equal to minus 0.71. So, this similarly, so this is nothing but is equal to 0.71. So, we got that z dash is equal to 0.71, which implies x dash minus 12 by 4, this is equal to 0.71, which implies x dash is equal to 12 plus 4 into 0.71. So, that we have to just compute it. So, it is 12 plus 4, so 2 point maybe 284, 2.84, please check that this is correct. So, this is nothing but 14.84. So, this x dash value is nothing but 14.84. So, this is the one questions. So, similar type of question we can do. So, let us see some other any problem similar type of this problem. Let us see that. Let x is a normal random variate with mean 30 and standard deviation 5. Let us do another problem. Let x be a normal random variate with mean mu is equal to 30 and standard deviation sigma is equal to 5. Find the probabilities that one 26 less than equal to x less than equal to 40, 2 x greater than equal to 45 and 3 mod of x minus 30 is greater than 5. So, this problem similar type of the previous problem, you can also solve it, you can try it. So, just solution I am writing down here. So, here also we will take the transformation. Here it is given mu is equal to x is normal 30 and variance sigma square is 5 square. Then we will take the z is nothing but x minus 30 by 5, it is nothing but normal 0 1. So, using this and also taking the help of the table, we will try to find the all this probability. First probability, what we have to find? What is the probability that question 1 26 less than equal to x less than equal to 40. So, this is equal to probability of, so we will take this transformation 26 minus 30 by 5 less than equal to x minus 30 by 5 less than equal to 40 minus 30 by 5. So, this value. So, this is nothing but, so if you x minus 30 by 5 is z random variable. So, this is nothing but probability that 30 by 6 minus, so this is nothing but minus 4 by 5, this is minus 4 by 5, I think, I hope it is correct, and then less than equal to this is z less than equal to, this is 40 minus 30 is nothing but this is 10. So, 10 by 5 is nothing but 2. So, this is probability that it is nothing but minus 0.8 less than equal to z less than equal to 2. So, how we will find this value? So, finally, we have a normal distribution. Suppose we are considering the standard normal variate. So, suppose this is the standard normal variate. Now, we want to find probability z greater than equal to minus 0.8. Suppose this is minus 0.8 and also it is greater than less than equal to 2. So, suppose this is minus 0.8, this is 1, 1, 2. So, this is this area they want, it is asked that find this area. So, this is nothing but probability that z less than equal to 2 greater than equal to minus 0.8. So, we have to find the probability that minus 0.8 less than equal to z less than equal to 2. So, it is not exactly coming. So, z less than equal to 2. So, how we can find that? First of all, total area is 1. So, we can find what is the probability this area. So, this probability we can find. So, then half minus of this we will get this area, and also this area we can find how. So, by mirror image, like it is a symmetric. So, 2 will be here minus 2. So, then this area will be same as this area. So, then we will take again half minus of this, we will get this area. So, I think 2 times we have to find, it is just this. So, first of all we find that what is probability z less than equal to minus 0.8 from the table. So, from the table how we will find, because it is a negative number. So, this table is given. So, 0.8 is here. So, this is 0.21186. So, 0.21186, 0.21186. So, we want probability not that, we want that this area. So, this area actually nothing but probability that z is greater than equal to minus 0.8 less than equal to 0. So, this area will be nothing but 0.5 minus 0.21186. So, this area. So, this area actually corresponding to this. So, this area. So, this is just we have to subtract this. This is 4, 1. So, then 8, then 8 and then 2. So, this is nothing but 0.28814.